Doing a follow-up video on doing the calibration table for the temperature sensor that I installed and set up. I'll link to the previous video that I did where I kind of figured out the values that I needed, but I did find a better way to do this using the actual resistance values for the sensor and do some calculations in Excel. And it's pretty close to what I had before, but I figured I'd show the proper way to do this so you get much more accurate voltage readings for your ECU. Just a much better way to do it rather than having to guess. So what I have is the low dollar temperature sensor. I'll link to it again in this video. And what they do is really nice. They actually, in the package I got, it had the values printed out, but also on their website they have the values. So down here they've got the video focus. Sorry. You've got, Celsius, Fahrenheit, and the ohms, the resistance value at the different temperatures. So what I did, just copy the text from the page, pretty easy. Go to Excel, open up a new sheet, copy and paste, or just paste them into your Excel. You get these three columns here. Added a fourth column for voltage. That's what I actually need to provide to the ECU, and then just a cell for the resistor value. So the resistor value matters quite a bit. You could go with anywhere between a 1,000 ohm to what I have, a 2,200 ohm, maybe even a 5,000 ohm. Whatever that value is, you'd plug that in here and it would give you the voltage. So it doesn't really matter. It might matter to some degree what kind of resistor you use. Maybe there's a certain range you want to use, I'm not even sure. But this is what I use based on another video, and I think it's going to work fine. So the calculation is going to be, the formula is going to be in the cell for voltage. So I'll zoom in here. So you've got equal sign 5, and 5 being the maximum 5 volt of the signal you're providing to the ECU, divided by, and then the sum, C2 plus E2, C2 being the resistance value, E2 being, or the resistance, okay, I'm sorry, the resistor value you'll get at a certain temperature from the sensor, plus the resistor value that you're adding into the circuit. So this is the pull-up resistor value. You add those together, and then you multiply that again by the resistance value of the sensor at that temperature. So what I get is a almost 2 volt value. That's the low end for 0 degrees Fahrenheit. That's, pretty low. And then once you've got that formula in there, you get that almost 2 volt value. You just drag it down to the bottom, and it should fill all the values here down to 3.6. In the previous video, I had about 3.5 there. So it's a little off. And that's how you do it. So if you build this spreadsheet, you can plug in any resistor value and even any resistance value of the sensor. Maybe you've got a different sensor, you can plug that in here along with the corresponding temperature, and you can build this voltage calibration value pretty easily. So then you go into Terminator X to your oil temperature sensor. So you've got this input. You go into inputs, you've got oil temp, go to configure. You can set all this stuff up how you like, but down here is the calibration table. You're basically putting the same numbers in here, so 0 degrees Fahrenheit to 300 degrees Fahrenheit, the max. and then 1.99 is the min on voltage that corresponds to 0 degrees Fahrenheit to 3.6 for 300 degrees Fahrenheit. The key here is put that min temperature and max temp here and on either end, and then you just kind of go across. Sorry, this laptop is not very sensitive. You go across, highlight all the cells. Whoops, that didn't work. Anyway, you highlight all the cells, you right click, say fill row values, and that will fill all the values evenly across. So you can see it's in increments of 20 all the way across. You could plug them in manually if you wanted to, but this is a little easier. Same deal down here. Put in your 1.99, your 3.6, drag across, fill row values, and it should evenly distribute the voltage values. And you should get a straight line there all the way across. You shouldn't be curved or crooked or anything like that. And that's how you do it. Upload that to your ECU, and the temperature sensor that you're working with should get the right voltage values and report the correct temperature. So that was the final video on setting this up the proper way, rather than guessing the way I did before. So good luck. Let me know if you have any questions.